All right, hello, welcome back. So this week we're going to have a conversation about the evolution of stars. We're going to be looking at the HR diagram quite a bit, so I want to take a minute to review the information that we can get from this plot. Okay, so here is a version of the HR diagram. So let's take a second to remind ourselves what data is plotted here. So remember the y-axis, right? The vertical axis here is luminosity. So how much energy a star is putting out. As you go up, the luminosity increases. So we have low luminosity down here, high luminosity up here. One right here, this equals the sun. So going up from there, you get brighter than the sun, and down you get dimmer than the sun. The x-axis, right, this horizontal axis here is temperature or equivalently the spectral class. So one weird thing about this plot that you need to remember is that temperature increases to the left. So O and B stars over here on the left side of the plot are very hot. M stars over here are the coolest. Okay, we can kind of roughly split this diagram up into quadrants. So in the upper left, up here, we have stars that are both very luminous and very hot. So these stars are on the left side of the diagram, meaning they have very high temperatures, and they are located towards the top, which means they have high luminosity. So moving kind of clockwise in this direction, we see that there are stars that are bright, but actually relatively cool. So stars that live here are the giants and the supergiants. These are very luminous stars that are also very cool. So how can this be? Stars can be luminous for two reasons, right? They can be very hot, like stars on this side of the plot, or they can be really big. So these giants and supergiants fall into the really big category. So that's why they can be very luminous, but also very cool. Moving down the plot, we get into the quadrant that has the dim and cool stars. So these are stars that are mostly a fraction of the mass of the sun. They're very small and they're not very hot. So the last quadrant, we're back over here. This houses the dim stars that are very hot. So these kind of mostly consist of white dwarf stars, and we'll talk about them in a later lecture. But basically, these are kind of the carcasses of stars that used to be on the main sequence here. So white dwarfs in this, dim and hot region, they're very small, something like the size of planets, but still very, very hot from their time as a hydrogen fusing star. So they live down here in the bottom left quadrant. So I mentioned the main sequence, and that is this kind of nearly diagonal line that kind of crosses from the top left to the bottom right. So most stars exist somewhere on this diagonal. Where a star falls, though, on this diagonal depends on its mass. So of stars on the main sequence, the hotter it is, the more massive it is. So there is a relationship between the luminosity and the mass of stars on the main sequence. So up here are brighter stars, and these are more massive. Down here we have dimmer stars that are the smallest stars. So stars spend 90% of their lives on the main sequence. The giant and supergiant branches and this cloud of kind of white dwarfs down here, They give us a clue to what happens when stars leave the main sequence and start to enter kind of their twilight years. So we will talk about that in the next couple of lectures.